Morgan, madam, you can start, madam. Hello. Hello. Hello.
Hello, can we start?
Yes, sir. 1 minute, sir. Morgan,
Okay.
madam. One minute, sir. Madam, you can start. Madam, you can start.
Hello all, good evening one and all. I'm Mohanalila, Assistant Professor VJIT. I welcome you all for today's session on V2X Beyond 5G Trends Technologies. Let me first, before starting the session, let me introduce our today's speaker, Dr. Joshua Samuel sir. Dr. Joshua Samuel is a senior lecturer at the Asia Pacific University of Technology and Innovation, Kuala Lumpur, Malaysia. He received his PhD degree with the Faculty of Computer Science and Information Technology, University Putra, Malaysia. His academic and research work focuses on cloud computing, parallel and distributed systems, energy efficient scheduling in data centers, artificial intelligence, and cybersecurity. He has received several recognitions, including Best Paper Awards for his contribution in the security and cloud computing, as well as institutional awards for long-term service and outstanding student results. His areas of expertise are cloud computing and virtualization, energy efficient scheduling and VM consolidation, artificial intelligence and machine learning, cybersecurity and threat detection, distributed and parallel systems, edge cloud continuum and intelligent systems. Thank you, sir. It's my pleasure to introduce you to all the participants. Now I request Joshua, sir, to continue with the session.
Thank you. Thank you for the introductions. Is I'm audible to you all?
Yes, sir, you are audible.
Okay, so let me share the screen.
Sir, now you can share your PPT, sir.
Yes. I'm doing that.
And you are closed.
Okay. So, is my PPT visible to you all?
Yes, sir. It is showing references.
Yeah. So, can you?
Yeah, yes, sir.
Okay, so
Yeah, proceed.
Once again, good evening to all. So I won't take much time. Already, I can know that it's night time over there. So I'll try to finish off my talk as quick as possible. So the topic that I'm going to discuss with you today is on Edge Cloud Continuum for V2X beyond 5G, challenges and opportunities. So what are the contents that we are going to see today? So we'll go through the motivations, what motivate me towards this particular topic, and what is V2X, why Edge Cloud Continuum, architecture overview, why beyond 5G for V2X, why not only 5G. We'll see something on 6G. Then I have one small case study that is from BMW Ericsson, and Ericsson, the collaborations between them and how they implemented this edge-based V2X AI prototype. Then some key challenges that still need to be addressed and the opportunities. So these are the things that we are going to discuss in this particular session. So when we talk about our 5G, nowadays you can see, okay, with the proliferation of technology, with the improvement in technology, okay, we need that our mobile technology should also be strengthened, So initially, once upon a time, the generation of mobile technology started from 1G, but now we are not stick to that 1G. We have gone far away from 1G. Okay, why? The one thing is that the requirement, the need, the necessity. Okay, the necessity is the invention, is the mother of all invention, we say. Okay, when the necessity improved, when there is an improvement in the technology and everything is connected with the mobile technology, so it is very important to improve the mobile technology. So nowadays we had 3G, then we had 4G. Now the current one we are using 5G. Okay, maybe in some of the countries it is not implemented, and there are many countries implemented. Okay, now the 6G is going to come up. Okay, so what makes this different? They want to, with the improvement in the technology, okay, they want to improve the bandwidth. They want to minimize the latency. They want to make that the network should be available to everyone. Okay, so that is what make them to come up with different types of generations. Okay, so here when we see about the motivations, okay, the 5G, okay, for vehicle to, when we talk about V2X, vehicle of everything. So in this vehicle of everything, there are many things like we have V2V, V2I, okay, V2P, okay, then V2R, okay, there are many things are there, okay. So what is the main thing is that for vehicle of everything, okay, we need to have a low latency, okay. So that is why we need to think beyond 5G. We cannot stick on with the 5G. We need to go beyond 5G. Okay. So nowadays we can see many autonomous vehicles on the road. Okay. If you see Mercedes, BMW, not only Mercedes, BMW, not only all these big cars, the small cars nowadays. Okay. In Malaysia, we have Perodua. Perodua, they have one version called Myvi. Okay. It's a very small car. Okay. But still, okay, those car has got this autonomous vehicle system like detecting the speed of the car that is going in front, the distance between the two car. If that car is going in certain speed, then automatically the car is coming behind that. Okay, will communicate with the car that is going front. Okay, will apply the speed according to that. Okay, if the driver is sleeping, if there is no movement from the driver, the car will give the alarm to the driver. It will apply the brake automatically. Those type of things. That's not a very big car, but it's a very small car. Like in India, we have Maruti, Tata. The same way in here, we have Perodua and Proton. Okay, so Perodua, they have this type of features. But why I more focusing on this cloud? Even though the cloud is my area of research. Okay, it's my research area. And why I'm focusing more towards, especially in cloud, why I'm focusing more towards edge cloud. Okay, for this particular V2X. That is what I'm going to discuss today in this particular sessions. Okay, then we are thinking beyond 6G, not only with the 5G, and why we need to think beyond 5G. Okay, so when we talk about what is V2X, V2X stands for vehicle to everything. Okay, which includes vehicle to vehicle communications. Okay, if there are two vehicles going, one vehicle is going in the front, other vehicle is is behind. Okay, so communicating with these vehicles, understanding at what speed they are going and adjusting the speed. Okay, then if the driver is drowsy or the driver is feeling is sleepy, automatically applying the brake by analyzing the distance between the two cars. Okay, so that is what vehicle to vehicle communications. Vehicle to infrastructures, for example, we have roadside units. Okay, for example, such as for when you talk about roadside units, what is the purpose of roadside unit? Like sending the traffic signal timing to the cars, means the car receiving the traffic signal timing from the roadside unit, and also the car sending their data to the roadside unit. Okay, understanding the pattern of the road, understanding the traffic in the road, okay, through the roadside units. So that is what called as vehicle to infrastructure. Vehicle to pedestrians, understanding the behavior of the pedestrians on the road. Okay, let's say if a car is going to a particular place and the car is 2 kilometers away from that place where there are too many pedestrians are there. Okay, and that place is full of like for example in Hyderabad, if we talk about Charminar, okay, you know about Charminar. It's a heavy traffic area with people walking on the roads. Okay, so before reaching to that 2 kilometers away from that place, understanding the traffic behavior, and then driving according to that for the safety of the people and considering the road safety. Okay, then vehicle to. So what is the main goal? What is the main goal of vehicle to everything? The main goal is road safety, cooperative driving, congestion reduction, to reduce the congestions in the road, and environmental awareness. Okay, so in nutshell, if I want to say, safe driving. Okay, the main aim and the main goal of vehicle to everything is to have a safe driving. Okay, so why we need to focus on edge cloud continuum? So when I talk about cloud, okay, cloud is nothing but we all know about cloud services. Okay, it is a service provided by the cloud service providers. Okay, over the internet through pay as you use. Okay, so these two are two different. We have a traditional cloud in one hand, and on the other hand, we have edge cloud. So what is this two, traditional cloud and edge cloud? Okay, so first let us see about traditional cloud. So when I talk about traditional cloud, they are with the cloud service providers. Okay, for example, Amazon Web Service, Azure from Microsoft, Google Cloud from Google, okay, Alibaba Cloud from Alibaba. So they have some cloud service providers. And in every country, they will be having something called as region. If I talk about India, in India, we have Mumbai as one of the region for AWS, and another is the Hyderabad for the AWS region. Okay. So they will be having in the region, they'll be having some availability zone. Availability zone will, they may have within a region, they may have 2 or 3 availability zone. Okay. So these availability zones are synchronized with each the data centers, and each availability zone will be synchronized with each other. So the services, let's for India, for whole India, okay, if they are using AWS, then their service provider will be in Mumbai. The region will be in Mumbai or in Hyderabad. Is it clear? So all data transmissions throughout India, okay, not only throughout India, if let's say Singapore, if let's say Sri Lanka, if there is no region, if they are collaborating with us, even they can also deploy their data, deploy their applications, okay, in our region. So here what happens, too many data will be transmitted, okay, the data there will be huge amount of data transaction, which will be in a terabyte, petabyte, hexabyte size, okay. So we cannot say everywhere, and this totally depend on your network speed, the bandwidth of the network. We cannot say that everywhere the network speed will be the same. Somewhere it will be fast, somewhere it will be slow. There will be some network disturbance. Okay, so it takes a lot of time, to process the data and send back the response. It takes a lot of time. But whereas when I talk about edge cloud, okay, edge cloud is also a type of cloud service where the cloud resources, okay, are located near to the end users, okay, whereby the data's no need to go to the traditional cloud, but can be processed and can be accessed from the nearby location. Okay, let's say, for example, I'm in Kuala Lumpur. Okay, in Kuala Lumpur, I'm in a place called as Bukit Jalil. Here I can have 3 or 4, okay, for 3 or 4, sorry, I can have 3 or 4 edge cloud locations, and I can get services from that. So why I'm not focusing on the traditional cloud, why I'm focusing on edge cloud? Because to reduce the latency, and this edge cloud will be near to my locations, okay, so that as quick as possible, I can get the service done from there. Okay, so that is why I'm focused. That is why for V2X, for vehicle to everything, there should not be any latency, because if you see, if you're driving a car, okay, at a 90 km per hour, okay, you can know the speed, right? So how fast you are moving, okay? So before you reach to one location, you must get all the informations, the road condition, the traffic conditions, okay, then the weather conditions, the traffic signal timing, everything you should get before you reach that place. So you're driving at 90 km per hour, okay, so you know how fast you're driving, okay, so it should be very fast, okay. So if I still rely on the traditional cloud, definitely, okay, I cannot receive the data as much as quick as possible that I need. There will be a delay. So that is why I'm depending on this edge cloud. Okay, so as I already told you, it is a cloud service provided. It is a cloud service where the resources are provided near to the end users. Okay, so near to the end users. So nowadays we can see, okay, we have many autonomous vehicle on the road, okay, which generates the data in a terabytes. Okay, the days of megabytes, gigabytes are gone. Nowadays they all terabytes, petabytes, hexabytes. Okay, so these data are being generated to various sensors like LiDAR, radar, cameras, and sensors. The data are being generated from your car, okay, or from your devices, and these data need to be sent to the cloud. Okay, so we need something that is near to our locations, okay, and can access as quick as possible. Okay, so this edge provides a real-time analytics close to the resource, okay, close to your devices. It can provide you can do some analysis and provide the result on that. Okay, we can still depend on the cloud. We can still depend on the traditional cloud. Okay, the edge cloud can be connected with the traditional cloud for the backup purposes, for the storage, backup, okay, and or if you want to archive the data, okay, So for example, if I talk about AWS has got something called Glacier, deep glaciers, okay? They are called as archiving services, okay? To archive the data, I can still connect with the cloud, okay? So that is why we are focusing on cloud, edge cloud continuum, okay? Continuum means continuous, providing continuous services, okay? So through edge cloud, we are getting the service continuously, so that, and also why I'm focusing on edge cloud is because we need something that can reduce the latency, improve the bandwidth, and reduce the latency. Okay, so the architecture of this particular, according to the various research papers, okay, the architecture overview of the edge cloud computing. Okay, so we have different layers, and under this edge cloud, okay, continuum for V2X, we have various layers, such as the first layer is called as the device layer. Okay, so device layers such as your vehicle, onboards, the sensors which are kept inside your vehicle. Okay, the sensors that you are having, such as your mobile smartphones. Okay, the smart watches. Okay, then we have an edge layer where we can find multiple access edge cloud. Okay, not one, within a location. Okay, within a cell, I can say that within a cell, okay, I can have 4 or 5 edge clouds. Okay, no need to have only one, I can have 4 or 5 edge clouds. Okay, and from where I can get the services continuously without any delay. Okay, that is called as MEC. Okay, multiple access edge cloud. Okay, serve low latency tasks. Then next layer is the cloud layer, where your edge cloud is connected with the cloud layers. Okay, so that's a global model training coordinations. Then we have the orchestrations layer, where AI decide task placement. So based on the AI, nowadays we can see the world is behind the AI. Okay, so the analysis must be done quickly. Okay, the output must be given as quick as possible. The analysis must be done based on the previous historical data, okay, about a particular location. The information must be sent to the car. Okay, so all these are done, okay, based on the AI. Okay, so this is the layer. This is the architecture of the of your edge cloud continuum for V2X. So here you can see in this particular picture that I have taken. Okay, so this is the device layer, where we have our cars. Okay, cars contains different type of sensors. Okay, like as we have seen over here. Okay, we have different type of onboard sensor. Some sensors are used to sense the road conditions. Some of them are used to sense the signboards, okay, on the road. Okay, I remember one of my student, he was from Africa. Okay, he has done, he identified the problem in their country. He said that the signboards are very, very poor in their country. Okay, sometimes the signboards are broken, they are bent. So when the cars are moving, the signboards are not visible. Due to that, many accidents are taking place. Okay, so he came out with some type of project. Okay, he implemented the sensors. Okay, so that the car can, the sensor in the car can sense, okay, before few kilometers away, okay, and can tell the driver that what that particular signboard is. Okay, sometime in some countries, due to heavy rain, okay, or this signboard might have got damaged. Okay, so such type of things. Okay, so such type of projects, okay, that particular student have done already. Okay, so here you can see these are the devices. Okay, we have different cells. Cells means the locations in our mobile technology. The regions or the locations are called a cell. Okay, we have multiple cells. Okay, and these cells, okay, these devices, so-called car or the smartphone used by the pedestrians, okay, the data are generated. The data are generated, okay, and these data are received by the nearby edge servers. Okay, we have multiple edge servers. Can you see edge server 1, edge server 2, server 3? We have, and so in a cell we can have 3 or 4 edge servers. Okay, now these edge servers, what they do, they receive the data. They work vice versa. They receive the data, okay, from these devices. They process the data. Okay, they process the data and send the output to this particular device. For an example, let me give you one small example. Okay, let's say, okay, you are in point A. Okay, within another 2 or 5 kilometers, okay, or within another 2 kilometers, there's a huge traffic. Okay, that's a huge traffic created by the pedestrians. Okay, means many, that particular, like our Charminar. Okay, many people are walking on the street. Okay, now this car is going towards that direction. So how this car will come to know? How this car will come to know? Yes, huge pedestrian movement is there. People are walking on the road. It's a huge crowded area. Okay, so I should keep up certain speed. Okay, so how they will know? Now these people all are using smartphones. Okay, Bluetooths are there. They are using variables. Okay, so from each people, the edge cloud will receive their data. Okay, will receive the data. Okay, so let's say I'm in this point. I am in this point. Okay, I want to go to this this point B. Okay, there's a huge crowd. There's a huge traffic. Okay, so this edge cloud will receive the data through their what we call as through their devices, which is used by the pedestrians. Will do the correlation analysis. Okay, we'll do the correlation analysis and send it to the nearby edge server, because all of them are connected over the network. Okay, we'll send it to the nearby edge server. So any vehicles in that particular locations, okay, in this location, or within certain kilometers, within the range of certain kilometers, okay, they will receive those data, and based on that, the driver can decide. Okay, and it will say at what speed you should drive. It will also give the decision. It will take the decision. Okay, it will process. Okay, the AI applications will be done. Okay, the processing will be done to send the signals to the devices. The car drivers will read the devices, and it will also come to what speed they should go. What's the condition of the traffic over there? Okay, now these data will be sent to the traditional cloud layers. We have a traditional cloud layer. Okay, we have a traditional cloud layer servers. Okay, which runs on virtual machines. We have storage. Okay, it will be sent to the database, will send to storage, will be stored over there. Okay, and for the further processing in futures. Okay, for the future processings and all. Okay, sometime from here also the edge servers. Okay, sorry, the edge servers can communicate and get the data from the cloud layer and send it to this particular what we call as to the cars, okay, to the devices. Okay, the same way, it will also helpful for the pedestrians to understand, okay, the movement of the vehicle in that particular area, so that they can have a safe safe transportation, or to keep the road safety in their mind. Okay, so this is another one more architecture overview. So here you can see, okay, car one, this is called as the communications between the cars. Okay, here you can see car one is communicate with car two. This is called as V2V, vehicle to vehicle communications. Okay, so this vehicle to vehicle communications, okay, we call them as a vehicle nodes. Okay, has got two things. One is vehicle to vehicle communication, another one is vehicle to infrastructure, V2I. Okay, this vehicle to vehicle communications is the communication exchange between the two or more than two cars in a road, okay, within a certain kilometers. Okay, so this is mainly to avoid the collisions. First thing. Second things, to understand at what speed the cars are moving, so that we can also drive according to that particular speed in order to avoid the accidents and all. Is it clear? Also share the hazard, okay, hazard data and all. Okay. Next one is V2I. The cars, okay, which are in the road, okay, can communicate with the V2I. So when I talk about V2I, okay, vehicle to infrastructure, such as roadside unit, you know, we have something called roadside unit. They also contain the edge servers. Okay, so this is to get the informations, okay, about the traffic signals, timing, road condition. What is the condition of the road in that particular location? Okay, let's say you are driving from here. Okay, after a few distance, when you drive, okay, you can see the roads are not in a good condition, so you can prepare before you reach to that place. Okay, I remember, you know, I remember one incident took place in Kerala. Okay, where the people, they used the Google map. Okay, and finally they landed in a river. Okay, the car fell down in a river because of not proper accurate, because of the latency, the latency, especially there are some places, okay, especially there are some places where the network speeds are very, very slow, okay, the GPS coordination, you may miss the GPS coordination, and then after some time, okay, you will get the GPS because there's a delay in the communications, okay. So through this edge cloud, okay, we can able to reduce those latency. I can avoid, okay, those type of those type of accidents and all, okay. So we can communicate with the roadside units, okay. The car can communicate with the roadside unit. The car can send their data to the roadside unit, and also can receive the data from the roadside units, okay. We have car communicating with the pedestrians, okay. So how the car can communicate with the pedestrians? So the pedestrians, they'll be having smartphones, they'll be having something called wearable device like smart watches, okay. Through that, the cars, okay, so the data will be received by the nearby edge cloud. The cars can communicate with the edge cloud, or the cars can also communicate with the pedestrian devices, okay, to know about the conditions, the traffic conditions of that particular places, okay. Finally, all of them, okay, are connected with your cloud servers, okay, your edge cloud, okay. And finally, the edge cloud is connected with the traditional cloud servers for the backup process, for your archiving process, for some kind of analysis, okay. So this is the overview, okay, of your of the edge cloud continuum for V2X communications, okay. Why we need to go beyond 5G, okay, why we want to think, okay, not we don't want to stick with the 5G only, why we are thinking beyond 5G, for especially for vehicle to everything, okay. So main thing is that first thing is the speed, okay. 5G provide during the peak hour, the 5G provides up to 20 gigabits per second, okay, remember 20 gigabits per second, but the data that are generated by the devices, that is by the vehicles, okay, are in terabytes, petabytes, hexabytes, okay. It's depend on the locations and the traffic conditions, okay. Latency, okay, the 5G, okay, it can minimize the latency around 5 milliseconds. Frequency, it operates at the 5G operates frequency of 6 gigahertz and millimeter wave bands. Capacity, okay, can support up to 1 million endpoints per square kilometers, okay, 1 million endpoints, okay. If you ask, is it 1 million endpoint? Will it not support beyond 1 million? Yes, it can support, but your bandwidth will be consumed, okay, that much bandwidth will be consumed, okay. So the key features, okay, so the main use of this 5G is provide a good and a fair service to AR and VRs, okay, and also for IoT expansions, okay. So that is what this 5G is all about, okay. So when we go about 6G, okay, the next one, that is 6G, okay, already China, we know China is moving far behind in technology, okay. We can say that China and Japan, they're living in 2050, whereas we are still living in somewhere else, okay. We are in 2025, but still far behind, okay, than China and Japan, okay. So still the 3GPP project, okay, is still going on for the 6G, okay. And these are some of the theoretical, okay, some theoretical values are given. Speed, okay, it can provide up to 1 terabits per second, okay, which is 1000 gigabits per second, 100 times faster than 5G. Okay, so we need something, that can transmit the data that are generated by the cars, okay, and send it to the edge cloud servers, and from the edge cloud servers, send it to your car devices, okay. So both side communications, okay. Latency low as 1 millisecond. So here we can see, okay, around 5 milliseconds, here says that 1 milliseconds, okay, so far better, okay. So when the speed is increased, definitely the latency will also be decreased, okay. Frequency in a terahertz, okay, so that is higher than 5G. Capacity can support more than, here 5G supports only 1 million, it can support more than 1 million. Okay, much large number of endpoints and devices. Okay, so what are the key features of 6G? It have integrated edge computing. Okay, advanced AI capabilities and support next generation applications. Okay, so especially when we need or when we look onto V2X, okay, we need much faster bandwidth and low latency. Okay, so that the communications can be received as quick as possible. It's not that you are 2 kilometers away from a crowded area. You are in a car 2 kilometers away from crowded area, and you never receive the signal. You near to the 1 kilometer also, you never receive the signal, and you got a signal. Okay, you receive the message or you receive some kind of informations. Okay, only when you reach to that location. Understood? No, it should not be like that. So that is why to improve those things, we are moving towards edge, cloud, okay, and also we are moving towards 6G, not only remaining with 5G. Even in upcoming days, 6G is also not sufficient. We may have to go for 7G, 8G, 9G, and all. Okay. So here there is one case study, you know, from BMW, and there's a collaboration between BMW and Ericsson. Okay, and they conducted collaborative trials, okay, on multi-access edge computing, okay, to improve the V2X performance. So what the main aim, the project focused on using low latency edge AI inference, okay. So what was the purpose of this BMW and Ericsson AI prototype, okay? First purpose is to offload computation from the vehicle to edge servers, reduce reaction time for safety critical decisions, and support latency sensitive autonomous driving functions. So this is the purpose of that particular prototype. So they focused on some of the key features. So the prototype focused on certain key features, such as the first key feature was, okay, multi-access edge cloud assistance for vehicle to everything communications. Okay, so what they did in order to, for this first feature, the Ericsson, they have their own MEC node, they have their own edge cloud nodes, and they deployed those nodes near the roadside. They have put some test bed, okay, to test their prototype. Okay, then the vehicles are connected over 5G NR and offloaded tasks such as object detection. So the vehicles were connected with some of the sensors to detect the object, for trajectory predictions, for cooperative perceptions. Okay. The second key feature of the prototype was AI inference at the edge. Okay. So instead of processing all the data, what they want, that the data should not be processed on board devices, that is in your car itself. Okay, it should be the vehicle must send the sensor data to the MEC. That means the vehicle must generate the data. That data must be sent to the nearby edge server. The edge server must do the processing and send back the response to the car. Okay, as quick as possible. Okay, so they have the edge executed real time. Yeah, so they use computer vision plus predictions. Okay, so with some cameras and all they have done. Okay. And they got a very extensive result whereby the latency was reduced. Okay, they received very low latency as compared to onboard data processing. Okay, so the another key feature, the third key feature is cooperative perceptions. Okay, where the edge clouds, okay, are aggregated camera feeds from multiple vehicles, from the multiple the data that are taken by the camera that are in the cars. Okay, they are being sent to this MEC. Okay, like multiple vehicles, roadside cameras, intersection sensors. Okay, the data are being generated from these devices and they are being sent to the edge cloud for the processing. Okay, so they got a very amazing result. Okay, the latency onboard processing was 30 to 50 milliseconds, but when we talk about edge based, okay, edge cloud, was less than 10 milliseconds. See here, 32 millisecond onboard processing, but when they tested on the edge cloud, it is less than 10 milliseconds. Okay, so they have reduced, okay, the latency as much as they can. The detection accuracy for onboard processing is standard, okay, but for the edge-based cloud is improved, okay. They have multi-view fusions. For vehicle CPU load, okay, no, the vehicle, okay, since they're having devices in the car, okay, they will be having CPU. So the load on the CPU is also reduced, okay. Because why? How the load is reduced? Because the processing are not done by the onboard devices, the devices in the car, okay, but they are done by the edge. Okay, so the sensor receives the data and send it to the cloud. Edge cloud will do the computations and send it back to the devices. Okay, so that is how the load on the CPU is also reduced. Okay, which improve the performance of the devices in the car. Okay, so some of the key challenges. Okay, even though there is a cloud, edge cloud is implemented. Okay, but there are still we need to focus. So there's some key challenges are there that we need to consider. Okay, still we need to improve. Okay, the latency should be reduced as much as possible. Okay, not 1 millisecond. Even if it is we should try to reduce up to, let's say, 0.1 millisecond, 0.2 millisecond. Theoretically, okay, it's possible. Practically, when we talk, is impossible, but need to do. Okay, the technology based on the research, okay, various scheduling algorithms, okay, can be done, okay, so that the latency can be reduced. Okay, service migration during high-speed mobility. So we know that, let's say we are driving a car, okay, we are in a point A and point B, okay. We are now in point A. In point A, we have one edge cloud. Point B, there's another one by edge cloud. Let's say we are traveling in a car at 90 km per hour, and nowadays the cars are not at 90 km per hour. Okay, here in Malaysia and all, we drive at 120, 130 km per hour, even 140 km per hour also. Okay, the Mercedes-Benz, BMW people, they drive minimum at the speed of 150 to 160 km per hour. Okay, so when the speed when they travel at such a speed, okay, the data received by this edge cloud, they will be distancing the cover. They will be covering the distance. The car, they will be covering the distance. Am I right? So the edge cloud must collect the data as quick as possible, must send from one edge to the another edge before the car reaches to that point B. Okay, must send the data to the car. Okay, so these service migrations, okay, should be done as quick as possible. Okay, interoperability across vendors and systems. We have various vendors who provide the systems, exactly the services provided by the vendors. Okay, security, and very important point, very important key challenge is the security and data privacy. Edge nodes. Okay, everything is connected with the network, and the hackers, the intruders, they're also connected with the network. If they hack the data, okay, and if they modify the data, okay, the vehicles will receive the wrong data, and the decisions taken by the drivers will also be not correct. Okay, and that can lead to some kind of disasters. Okay, so we need to have something okay, called security on data privacy. Okay, some kind of strong encryptions. Okay, or an AI-based encryptions must be created so that it can provide a good security. Energy efficiency is a very, very important thing, and that is one of my area of research also, energy efficiency for mobile nodes and roadside units. Okay, because when we connect too many devices, okay, and these devices are keep on continuously receiving and sending the data, edge servers are processing those data, okay, then 24 hours, okay, 365 days, okay, they will be keep on processing. Okay, so the energy that is generated, okay, by this edge servers, okay, will be huge. That can cause, okay, some kind of harm to the environment. Okay, can increase the heat in the atmosphere. Okay, so and also will consume the electricity bill will also be very high. Okay, so need to look into these areas, how the energy can be reduced. Okay, how we can make, okay, this edge cloud, okay, for V2X communication energy efficient. Okay, the opportunities like real-time cooperative perceptions for collisions avoidance. Okay, we can have some kind of real-time cooperations. okay, for the collision avoidance. Dynamic offloading based on road congestions and network loads. Then we can, there's another opportunity called predictive analytics via digital twins and AI. Okay, so these are the areas where we can focus our research. Okay, smart city integrations, connected traffic lights, emergency vehicles, scalable AI lifecycle like cloud trains model, edge executes them. Okay, the cloud train our model. Okay, and the edge cloud execute those applications. These are some of the opportunities. Okay, so these are some of the references I have taken to prepare this particular slide. Thank you. So any questions, if you have, you can ask me.
Participants, you can ask any queries. Or you put it in the chat box also. So unmute yourself and ask the question. Participants. Yeah, you can unmute and it. Yeah. Yeah, you can unmute now. Yeah.
Hello, sir.
Oh, yes, carry on.
Sir, please, can you just suggest some research opportunities for V2X with respect to 5G environment, sir?
Okay, when we talk about V2X with 5G environment, okay, the main thing is that you can do a research. If let's say you are focusing more towards the networking side, okay, when you are focusing more towards the networking side, you can do on improving the fairness of your network bandwidth and the data communications. Okay, because here the data is very, very important. Okay, the data that are generated, and this data should be transmitted between the edge and between the devices. Between these two areas, the data must be generated as quick as possible. So the fairness of your network plays a very, very important role. Okay, so when I talk about the fairness of the network, okay, data without any interruptions, okay, there should not be any failure in the networks. Okay, there should be a collision avoidance. Okay, so in those areas we can do the research.
Currently, I'm working on routing of these protocols, sir, from V2X.
Okay.
So, what could be enhancement in that particular domain? That's what I wanted to know, sir.
In that area, what if let's say you're working on a certain protocols. Okay, let's say for example you're working on certain protocols to improve, okay, the speed, okay, and to reduce the latency. My idea is go through some related protocols that are already been implemented by the researchers. Okay, see, we are not going to, when we are doing a research, okay, there are two things. One is you come out with some new protocol which is not there yet. Okay, second thing is that we can do some enhancement that is already available. Okay, so this you need to think which one you want to use, whether you want to go with a new protocol. So if you want to create a new protocol, then you need to study the existing protocols. Okay, what are the existing protocols available? Then identify the weaknesses in those protocols. Okay, prepare a review papers or prepare a review on that particular protocols. Then come out with your own protocol, do analysis between all these existing protocol and with your protocol to see the results.
Yes, sir. Yes, sir. Got it, sir. Got it, sir. Thank you, sir.
Thank you. Welcome.
Hello.
Yes.
So there are many edge computing devices. So is there special devices which are designed for V2X communication?
Actually, currently, there is no such devices, which means especially for, let's say, for example, for V2S communication, because most of the edge servers are provided by your service providers. Let's say, for example, your AWS, okay, your Azure, okay.
Yes,
So
yes.
yeah, they have their own servers and they are providing those servers, okay. But especially when I talk, okay, when I talk about, it's not all on the server, okay. We cannot only consider on the server only, okay. We cannot say that if I have a specialized server, okay, for this V2X, but we need to have a dedicated network, only for V2X. No?
Okay.
Because your data are being transmitted over the network, okay, between the device and the edge server, right? So we need dedicated network or some kind of scheduling should be done. So that like priority scheduling, okay, some type of scheduling should be done whereby, okay, whenever the data is generated from this device, from this vehicle, must be given high priority as compared to other data, and must be routed through a particular channel. That can be done.
Means, sir, there is no as such a role for edge computing devices. Means we are more concerned with routing algorithm. Means what? Yeah, just before that you said.
Yes.
Okay. So these are only the middle part, just to access the data and to transmit the data, like edge computing devices.
Now let's say, let me give you a small example. You are using a Dell laptop, okay, and let's say in your home someone is using HP. Okay, whether you use Dell or whether you're using HP, that's not a problem as long as you are getting a proper network services, right? Okay, as long as there's a good fairness in your network, right? That's the thing.
Okay, thank you, sir.
Welcome.
So one more question in chat box, sir.
Just a minute. Where is the chat box? I'm not able to view the chat box.
Chat.
Just a minute. Okay, I can see that. How can interoperability between the vehicle infrastructure and cloud system be ensured when different manufacturing services providers are involved? As there any, so for this one we need to follow the IEEE standard. Okay, we have different IEEE standards, Okay, so the vendors that who provides the services, okay, or the devices, whether they are IEEE certified or not. Okay, so just like when we go and buy an access point, okay, or let's say we are buying an Wi-Fi router, okay, for a wireless local area network. So it should have IEEE 802.11 standard, right? Okay, so that is very important to see. Okay, if you want to check the originality and make sure, okay, whether the services provided the vendor, the product given by the vendor is the right one, correct one, is a standard one. Yeah, we have to follow the IEEE standards. Okay, if the device is having that particular IEEE standard, then that's a well one. Okay, and also there are many configurations we need to see. We need to see, it's depend on our configurations. Okay, that's why I told you in the beginning. I said something. Okay, there will be a huge traffic in one particular locations. Okay, let's say let us take one particular state. Exactly, in one particular state, in one location there will be huge traffic, and if I go very deep inside the village, there will not be much traffic, right? Okay, so based on this, I can give the priority. I'm like, in this area I need to have a edge server with good configurations. Okay, but the area where the less traffic, that collects very less regularly, okay, on average it collects very less amount of data. So this is all about cost optimization. Again, we can talk about the cost optimizations over there. Okay, so what is the purpose, okay, in point A where there is a less traffic, okay, that is generated, and I put a very high end configured server, okay, high end server. Okay, so that also we need to look into that. Okay.
Sir, in case of this edge cloud computing, it
Okay.
is related to the source and remote data processing, right? If it is like this, how in order to achieve this latency management, will they go for any intermediate devices in between that, or there will be an automatic connection between this, sir?
Actually, when we talk about net, so now this comes under the area of networking. We know that we have repeaters. Am I right? We have some repeaters. Repeaters are connected in
Yes,
our
sir.
network. They receive the data, they regenerate the signals, they transmit the signal. This is all about regenerating and trans. But the main thing is based on the scheduling algorithms to improve the fairness of your network communications. Okay, so if you're doing